Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 7.2, Solving Systems of Equations by Substitution. It's the same idea as what we just talked about in our last section where we're solving a system of equations. We want to come up with a point where the two equations would cross if we were to graph them. But instead of graphing them, this should be a quicker and easier way to solve the system. Okay, the substitution method. By replacing one variable with an equivalent expression containing the other variable, you can create a one-variable equation that you can solve. So step one is to solve one of the equations for either x or y. How can you decide which one is easiest? Well, if 1 is alone, it is already solved. Another idea would be which of the two, x or y, is easier to solve. So if I just have 2x equals something, then I'm going to solve for that x, because all I have to do then is divide by 2. If I already have y equals, like in example 1, then I'm going to use the y equals to substitute into the second equation, like step 2 says. It says to take that equivalent expression and substitute in the second equation to find the value of the other variable. When you substitute to find the second variable, write it as an ordered pair. What does the ordered pair represent? The ordered pair represents where the equations cross when graphed. It would be where the equations would cross when graphed. Okay? All right, on to example 1. Example 1, I need to solve for an x or a y. In the first example here, both of my y's are solved for, so what I'm going to do is I'm going to take this negative x and plug it in for that y. Remember, every time that I've talked about replacing a variable with an expression or anything, I'm going to put parentheses. So I'll put parentheses negative x minus 1. So now I've replaced this y with this expression. Is equal to 1/2 x minus 4. Okay? Now, is there anything else I can do inside those parentheses? There is not. I'm not going to distribute anything, so I can just drop my parentheses. What I want to do is make sure that my x is positive. So because this x over here on the left-hand side is negative, that means I'm going to add it to the other side. The other x is already positive, so when I add to 1/2, then I'm going to get a positive number, right? So what I'm going to do is I'm going to move my negative x over to the right-hand side. So I'll add x. That would get me negative 1 is equal to 1/2 plus 1 would get me 3/2 x, 1 and 1/2, minus 4. Now I'm going to add the 4. That would get me 5 is equal to 3/2x. Now I have to get rid of the 3/2. To get rid of the 3/2, I'm going to multiply. I'm sorry, that's not 5. I apologize. Negative 1 plus 4 would not be 5. It would be 3. But my process to get rid of my 3/2 would be the same. I'm going to multiply by 2 on both sides. That would get me 6 equals 3x. Then I will divide by 3. So x would equal 2, positive 2. Okay? Now that I have x equals positive 2, what I'm going to do is plug it back into one of my two equations. Well, let's look at our two equations and see which one we think is easier. So I'm going to take this 2 and plug it back in for one of my two equations. 1/2 times 2 would be 1, and 1 minus 4 would get me a pretty easy answer. Or negative x minus 1 would be pretty simple as well. I'm going to go ahead and use this equation. So I'm going to take my x, plug it in for x. So I get y equals 1/2, remember parenthesis whenever we want to replace a variable, minus 4. What would go inside the parenthesis? Well, this positive 2. So y would equal 1/2 times 2 would be 1, minus 4, y equals negative 3. Now we're not done yet. My last step is to write as an ordered pair. So I need to write it as an ordered pair. So parentheses, x always comes first, 2, and negative 3, and we are done. Okay? On to example number 2. So actually that's my answer. and that would be the point where my two equations, or my two lines, would cross if we were to graph it. On to example number 2. I need to solve for either x or y. Well, x is already solved. So what I'm going to do is take this 19 minus y and plug it in for x. So parenthesis, 19 minus y equals negative 7. Notice all I did was take out that x and plug in what x equals, which is 19 minus y. Is there anything more I can do with 19 minus y? There is not. So it would be 19 minus y equals negative 7. 19 negative y minus y would be negative 2y, equal to negative 7. Now to solve for y, I'm going to subtract 19 from both sides. So that would get me negative 2y is equal to negative 7 minus 19 would be negative 26. Divide by negative 2. So y would equal 13. Now what I'm going to do is go back up to the top. I'm going to take my 13 and plug it back in for one of the y's. I can plug it into either one, but since this top equation already has x equals by itself, I'm going to take that 13 and plug it in for that y. So x would equal 19 minus parenthesis 13. I can't do anything else inside the parentheses, so it would just be 19 minus 13. So x would equal 6. My ordered pair would be 6, comma 13, and I am done. Okay? On to example 3. I have 6x minus 2y equals 10, or I have y equals 3x plus 1. Again, the y is by itself already, so I'm going to take this expression and plug it in for y. So 6x minus 2 parenthesis 3x plus 1 will be equal to 10. All I did is I pulled out the y, plugged in the 3x plus 1. From here, I need to take the negative 2 and distribute it. So that would get me 6x minus negative 2 times 3x would be 6x. Negative 2 times 1 would be negative 2. I want to combine like terms, so 6 minus 6 would be 0x. Minus 2 equals 10. Do I really need to write 0x? No, I don't. So negative 2 equals 10. That does not equal each other. So in this case, I would have no solution. Since I cannot find a solution for x, I could not plug that back into one of my two equations. Therefore, I would not be able to find a solution for y, and it would be no solution. As we know from our last section, if it's no solution, that means that those two equations are parallel to one another. Okay? Example 4. I have 2x plus 2y equals 8, or I have 7x minus y equals negative 4. In my opinion, it would be easier to work with the 2x and 2y, but you could also work with the 7x minus y. Either way would be fine, but what we need to do is solve one of the equations for a variable to start with. That y is kind of by itself, so if I go ahead and subtract 7x, I would get negative y equals negative 7x minus 4. Divide by negative 1. Y would equal positive 7x plus 4. Okay? So now, since I changed this equation, I cannot take the 7x plus 4 and plug it in for y in that equation. I'm going to have to plug it in to that equation. So it would be 2x plus 2 parenthesis 7x plus 4 would be equal to 8. Distribute my positive 2. 2x plus 14x plus 8 would be equal to 8. Combine like terms, so 16x plus 8 would equal 8. Subtract my 8. 16x would equal 0. Divide by 16. So x is going to equal 0. Now, some people like to try to take this and plug it back into that equation because y is already solved for. That will not work for us. I cannot take it to that equation. What I'm going to have to do is take it to one of my two original equations. Alright, so if I try to take it to one of my two original equations, I think that was an 8. I tend to like to work with the equation I did not plug into already. So I'm going to take the 0 and plug it into this equation. So it would be 7 times 0 minus y equals negative 4. Well, 7 times 0 would be 0 minus y equals negative 4. Don't need to write my 0, so negative y equals negative 4. divide by -1, y equals +4. My ordered pair is 0, +4, and I am done. That is the substitution method. You need to solve for one of the variables, then you're going to plug that into the other equation. Once you have solved that for a number, you're going to take that number, plug it back in for the variable it was equal to, and then solve that for the opposite variable. All right. If you have any problems with this process, please make sure you come and see me before school or ask during class, and we'll be rolling through this stuff, okay? Well, thank you very much for watching the video, and have a great day.